Good afternoon, and welcome back to another episode of my workbench, where I've slightly tidied things up, and I've also put up the Dell monitor that I've repaired earlier for all those who've been following along. You'll have seen me repair the power supply on that, and I've finally actually got the thing set up. Also managed to break and then repair this. Well, I didn't manage to break it, it kind of broke itself. The pivoting thing on the bottom there, where it swivels to and fro, is a little simple plastic pipe with about a 1.5mm wall thickness that managed to snap in half last time I tried to pull it forward. So I decided to glue that back together again, and I also put in I put a bolt. I took a steel bolt. I've actually got the end of it here. I took this bolt, I cut about this much off, stuck it up inside the pipe and glued it in with araldite, and that has seemed to work very well. So that was fun. Apart from that, I've also changed the height of my camera. I found this was a much nicer way to do it than to have to bend over like this all the time. I kind of can sit back straight now, and feels a lot more comfortable for me. So shouldn't impact too much on the video. In fact, you probably didn't even notice until I pointed it out. Okay, that's maybe not true. Hopefully, you're probably more observant than that. But anyway, so yeah, slight changes here and there. Nothing major so far. But yeah, there we go. In case you're wondering, things are slightly different, and they'll probably continue getting slightly different further along as things progress, whatever that means. Anyway, to the topic at hand. So the title of this video, at least I assume the title will be something about the importance of status LEDs on electrical equipment, and also possibly in reference to troubleshooting techniques. So I've had an idea to do with this monitor, which I'm just currently looking at, obviously. This monitor is a 19-inch HP, I'm not entirely sure the model name, 190 something possibly. I can have a look at the back, I guess. What is it? Okay, f1903, also product number P9627A. So yeah, it's just a basic monitor, nothing too fancy, but it's quite good. It's old, but it's a good one. I had it over there with the computer set up. I'm also going to set up a second computer actually to run this monitor, so I can have a something locally over here. I probably mentioned that before. Anyway, sorry, I'm just getting distracting myself now. But yes, this monitor here, what was I say? F1903. I've noticed twice now it's intermittently not turned on, and by not turning on I mean it basically does absolutely nothing. There is a power LED at the front which normally turns blue when it's powered up, and then will turn to orange if there's no signal, and the screen turns off obviously. But not getting a blue light, not getting an orange light, not getting anything at all. So obviously the power light at the front is controlled by the processor board, and if there's no light, it could be anything really. It could be one of these regulators on here is intermittently not working, could be there's something wrong with the processor, or what I kind of suspect, and I'll tell you why, is possibly the power supply itself, which is just a 12 volt thing. It just supplies 12 volts here, and everything else is done on the main board, like the 3.3 volts I guess, and 5 volts for the EDID ROMs and all that kind of stuff. And I'm assuming the inverter just runs straight off the 12 volts. There's probably like a 1.8 maybe for the panel signaling and all that, but anyway, apart from that, power supply, yeah. So the other day, 2 days ago I think, okay, I just slightly lost my train of thought there because I had to go and get some water because my mouth was running out of moisture due to too much talking, and now I've forgotten kind of what I was talking about. I think it was the power supply and why I suspected that it might be the fault. So yeah, when I plugged my computer in the other day, the monitor didn't turn on, and Normally what I do is I unplug the whole thing from the wall. I don't like to leave it on because it wastes power, obviously, in standby, and it creates an extra element of risk that it might suddenly blow up. Okay, that's not likely, but you know what I mean. So, I mean, consumer electronics aren't that great in terms of reliability, and sometimes they go up in smoke. So when you understand these kind of things and you can see how they are built, sometimes you don't often have a lot of faith in their ability to not catch fire randomly. So not trying to scare anyone here, but I personally don't like to leave things plugged in as much as possible. So anyway, so I plugged it in at the wall, and the monitor didn't do anything. There was no power light on the front, as I probably explained just before. So in the event that it was just a bad connection with the plug, or the cable had suddenly spontaneously died or something, who knows, it could happen. I swapped out the cable for another one, and didn't make any difference. So I thought that's a bit weird. While I was doing that, I was bent over the back of the monitor, obviously, as you do, and I couldn't hear any noise from the power supply, which you might think is a bit odd, because why would you hear any noise? But this particular one, I have noticed when the monitor is in standby mode, when it's not displaying a picture or anything, or when it's just been plugged in or switched on, the power supply goes into, I suppose, a kind of a power-saving mode, where it's probably not pulsing the transformer continuously. It's just sort of doing sort of sporadic bursts of pulses or something, and I think it's called pulse skip mode, and the transformer makes an audible sort of hissing, buzzing noise. When the monitor is actually running under full load, then the power supply is actually pretty much silent, and I didn't hear anything like that whatsoever. I didn't hear that telltale noise that it normally makes, so I kind of thought, well, maybe the power supply is just not running at all. And I have looked at the bottom of it, and I've noticed what appear to be some possibly cracked joints. Very slightly cracked, quite hard to notice. I had to look at it quite close up with magnification, but I will of course reflow all those, and maybe that'll fix the problem. I mean, who knows? Might be that there's just an intermittent connection problem, but it could also be something else. Maybe like a component is intermittently failing, it happens. Either case, I can't really say at the moment, because the faults only come up twice now. And that's the problem with intermittent faults. They're really, really annoying, because you never know when they're going to turn up. So I have an idea. Seeing as I think the power supply may not be starting up, or who knows if there's maybe an intermittent short circuit or something on the main board, or some such kind of thing that's shutting the power supply down, or maybe preventing it from starting at all. I don't know, but I kind of basically want to know, is the problem that there's no power coming from the power supply for whatever reason, or is it that the main board itself is not working? And that's an approach basically with all of electronics, or really with any sort of system, like a complicated system like this, is to narrow down the actual area of where the fault is. If you don't know where it is, I basically, at this point, it could be anything, really. Probably not the inverter, obviously, or the panel itself. Most likely it's either the power supply or the main board. But we don't know. I don't know. I have no idea. So I've got an idea that may help me figure out that if it happens again. And what I'm going to do is I'm going to put an LED on the output of this power supply. And I'm going to have it probably set on the side of the case, or I might just run some wires out through a vent hole and have it hanging out the side, or have it just pointed at the hole so I can see it if I look down to the top of the monitor. I'm not sure. But I'm going to put an LED on the 12 volt output. This is a 12 volt power supply, and if next time I notice that it's not turning on, there's no front panel light, it seems to be being a bit weird, what I'll be able to do is I'll be able to look through the hole, whatever, and see what the LED is doing. And the LED, if it's off, I'll know there's no power. If it's flashing, I'll know the power supply is trying to in a restart loop or something. Or if it's really dim, I'll know that the power supply is running, but it's not putting out enough power, and maybe the thing's not coming up because there just isn't enough voltage. So yeah, it could be anything like that. Good visual indication of what might be the problem, and well, like I said, at the moment I have no idea what the problem is, just that it won't turn on. And maybe it's a solder joint problem, but who knows. But yeah, that's my current thing, is basically just trying to figure out which area the fault is, and I don't know at the moment which one, so I'm going to use an LED to figure it out. So I just wanted to basically say that this video is basically just about the importance, but the helpfulness of putting status LEDs on things. And usually it's only really used in development. When you're making a product, you want to put LEDs on like each of the regulators. They might have like a status LED for each power rail. They might have one for the power supply. They might have one for each button input, so when you press a button an LED comes on, that sort of thing. Like when you're debugging the software, when you're doing all this kind of stuff, you want to know. You might have one for like the dimming signal going to the inverter, and I want to check, if that's all valid and stuff like that. And of course, they're going to have like logic analyzers hooked up to it, and scopes, and software debugging for the processor, and all that kind of stuff. But visual LED indications are very, very helpful to that sort of thing. But I also realized that they're also really helpful for troubleshooting as well. And I mean, you notice this with some TVs often. Will flash a fault code on the power LED if it detects a problem. So, which is quite useful, but things like monitors don't really do that. They just don't work. So yeah, I mean, as a rudimentary technique, it's a valid option, I think. Something I'm going to try and see if it yields any results. And yeah, just thought I'd talk about that and say that if you are troubleshooting something, if you don't know what's going on, it could be a really good idea to put a status LED on each power rail, for example, or any important control signals that you may notice. You might want to buffer it with a transistor or something, though, if you are looking at an actual logic level thing, that because like a processor might only be able to source like 10 milliamps or something out of an output to drive another input that only sinks like 5 milliamps or something. And if you suddenly stick an LED on that and try to draw 20 milliamps or something, yeah, you might blow something up. But so you might want to buffer it with a transistor or MOSFET or something. But yeah, I mean, because that's the problem with intermittent faults, is you have no idea when they're going to turn up. But if you had like an array of LEDs monitoring all the main rails, all the important power signals and status and things like that, control lines, like I just said, like maybe inverter power on and off and dim signal and that kind of stuff. Yeah, it might actually help troubleshooting. If suddenly the thing fails, you can just quickly look at your LEDs and say, oh look, the one for the 3.3 volt rail is off, and then maybe you find that the 3.3 volt regulator is intermittently just going open circuit or something. So it could be a useful tool. Yeah, so basically, probably fully exhausted all possible explanation of how this could be useful. So I'm just going to put my soldering iron where my mouth is. That might be a bit painful, not exactly. I'll actually put an LED on here somewhere, and we'll see what happens. And I'll make a future video, possibly, if I ever, if it's helpful. I'll make an update to this later on if anything useful comes of it. But I do think that it's quite possibly a really clever idea, because it enables you to get a quick visual indication of the status of a system without having to spend the time to get an oscilloscope out and set it up, and by that time the fault might have gone away, or the whole thing might have just completely shut off. Yeah, so anyway, obviously it's not going to tell you every single fault. It's not going to be helpful for really complicated faults or like signal integrity problems or something weird like that, but for really basic things, and often faults are really basic things. They're just like one power rail goes down, or there's a control signal somewhere that's not functioning properly because there's a shorted decoupling capacitor on it, or something weird like that. And things like that would be easy to find with something like that, especially if they're intermittent. So I think it could be a good idea, and I'm going to stop talking now because I've probably made this thing way too long. Okay, so I've done a bit of mucking around with it, and I've tested all the capacitors just in case, and they're all perfectly fine, which is not surprising, seeing as they're Rubicon and Nishikon, and they're all really good. And I've added a little LED here, which you can kind of see. It's just a white LED, a red heat shrink around it, and I've just tacked it onto the output terminals on the other side of the output plug. And I've added a 1K resistor there, so the current will be about 9 milliamps, given that the resistor will drop 9 volts and the LED will drop 3 volts, and we've got a 12 volt supply. So if I plug this in, we can see the light turns on, and of course the thing's going to be working at this time. So if I just bring this around here and push the button, you can see a little blue light comes on, and everything should make sense. So there we go. Obviously you get the no signal message, but we're not plugged in. But yeah, so next time if I try it and it doesn't work, let's turn this off again. See, hang on. Yeah, so that turns off, and obviously the whole time the 12 volts there, and we got that light. So this should be able to see through the top of the case when I put that on, and it should be fairly obvious. I'll just unplug that, and we can see the light stays on. Obviously the capacitors are still charged, the power supply is still going, and the light's gone off. So yeah, anyway, so next time when I turn it on, and if it oh yeah, well, of course, obviously I've also reflowed all the solder joints on the PSU as well. So like I said, some looked a bit kind of cracked and didn't look a very, very minor cracking, so maybe not the cause, but hey, you know, something to try. So I've done that and put this light on, and like I said, if it happens again, if it randomly doesn't turn on, then I can just look down through the top of the plastic case at the back here, and I can see if that light's on, and if it's not on, if it's flickering or too dim or something strange like that, then I'll know, you know, should get a better idea of what's going on without having to, you know, because by the time you take it apart, you connect the voltmeter to it, you've moved everything around, and suddenly it starts working again. So yeah, we've got to have something that's just there, it's permanently there, and should give some sort of indication as to whether or not there's any power when it decides to be weird, if it ever does that again. One of these slightly annoying monitors where you can't just take the back off the back, you have to take the back off the front and muck around with it, but should be alright. Now, if I can just find the screws. These are the screws here. Yeah, these look like the screws. Okay, hang on, this tape has been misaligned. It's kind of like conductive tape that they use for grounding things. So if you are taking a monitor apart or some type of device, then that tape is usually there for a reason. Sometimes it's just for EMI compliance and passing tests for government regulations and stuff, but sometimes it does actually feature into the design and the thing in a way that actually is kind of required. So it's a good idea to try not to just rip it all off and chuck it away. It's usually they put it there, you know. Again, these things are not made to be as expensive as possible. They're made to be as cheap as possible, and if they could get away with not putting tape on there, they would. So if it's there, there's generally a point to it. At least I'll say one thing for this monitor, it has a fairly easy to remove front panel, which is quite nice. And then of course we have the stand, which I've actually pinched off another monitor and which doesn't totally fit, so I have to put these little copper spacers here. Okay, so let's see if that makes sense. It should make sense. Plug that in. So you should be able to see there's some light sticking out there. Well, some light sticking out. And yeah, so gives a good thing, and obviously it doesn't affect any standard usage of the monitor. It's not in the way of the view or anything. It's not going to be annoying. You're not going to have a glaring light sticking in your face while it's running. There we go. It's currently it's working. So yeah. Hopefully this is a useful troubleshooting technique that someone will find comes in handy. Hopefully it comes in handy for me too. So far it seems to be quite a useful idea. Hopefully, anyway. So that's about it for this one, I suppose. So stare at the back of this dusty monitor, and I'll see you next time.